So we basically have a working game here. I guess one final thing to consider is what happens if there are no more creatures. So we could come down here and add one more part after this section here and say, if not creatures, and we'll leverage the implicit truthiness of collections. This is a list of creatures. If it's empty, that'll be false. So then we'll say print something like, you defeated all the creatures, and then we'll just exit. Like so. Let's just test that super quick. I'm not sure we'll be able to defeat the evil wizard of 1,000. So let's just, there is a theoretical chance, but it's not so high. So let's go over here and just comment out the wizard for just a minute. So here we can attack all the creatures. How many are left? Oh, looks like we defeated all the creatures. Well done. Game over. Perfect. So our game is working, but it's kind of bland. And, basically the only factor we have to consider here in the entire gameplay is that number. What is the level of our creature? And what is the level of our wizard? And then it's randomness. Do you feel like fighting a toad should be equivalent to fighting a dragon? Or fighting an evil wizard should be the same as fighting a standard like fruit bat? Probably not. Not only do they have different ways to fight, but the properties that you would take into consideration around how they would fight would be different. Maybe a toad's wartiness would have some sort of factor there. And if a dragon had scales, maybe you would consider like how thick his scales were, or if he was a fire-breathing dragon or something like this. But if we just use our creature class, let's go over to that. If we just use our creature class here, it doesn't model scales or wartiness or whether it breathes fire. It simply is the most common denominator thing that models all creatures, right? They have names and levels. And that's exactly what we want. We want to have this sort of commonality. So regardless of the type of creature we're fighting, we can just use that. Okay. So let's add one more feature that will give us a little flexibility to this creature class. And then we're going to look at how we create other classes based off of creature and use inheritance and polymorphism and that kind of thing. Let's add a method, say def, and we'll say get defensive roll or something like that. Now up here, we just had the creature do the roll directly here, but rather than do this, let's comment this out. And let's say we'll go to the creature and we'll say get defensive roll. And it's up to the creature to take all of its attributes into account. If it's a dragon, let's think about its scaliness. If it's a toad, its wordiness or whatever, right? We can make our game behave exactly the same if we just use sort of the same algorithm. We randomly compute our 1 to 12 number, that's throwing our 12-sided die, and then we're going to just multiply that by the level. And that's what the base creature does. But maybe we'll do something different for a dragon, if we can invent this idea of a dragon and so on. So let's just make sure we can still play the game. So we're going to look around, and we see a level 1 toad, so let's attack it. Excellent, the toad rolls 2. Let's look around again. Now we see the evil wizard. Let's attack it just to see that it's throwing something high. Oh, we've been defeated. It rolled 5,000. Of course we've been defeated. So now let's go back and think about our creatures here. We want to categorize these different things, these different fighters, into more specialized versions of creatures. So maybe a toad and a bat, maybe we would actually want to call these like small animals here. So let me just sort of sketch this out. So maybe these would be something that are like small animals. And small animals, well, it's singular, small animals would have the same properties as a creature, but maybe they would have some diminished sort of throw to save. Whereas a tiger is maybe this is a predator. Dragon, maybe this would be a dragon. And maybe to the dragon, we could say, scaliness equals 20, like whatever a scaliness factor is, right? And that might be considered when the dragon is fighting. If it has more scales, it's even harder to beat. And then similarly, maybe the wizard, maybe it has some type of magic, and it somehow takes that into account as well, right? So maybe we put a wizard here. Well, this isn't going to turn out really well for us so far. First of all, we don't have small animals, right? It's not a thing we're modeling. And we don't have a dragon. Let me just comment those out for a minute. We do have a wizard. Now, if I try to run this, it's probably not going to work so well. Oh, a wizard has appeared. Let's attack it. Oh, bam! The wizard doesn't have this concept of a defensive role. All the creatures in our game are supposed to sort of have this commonality of everything that is a creature and then some specialization in them. So let's take a moment and look at this core concept called inheritance that allows us to sort of layer on this specialization and shared attributes and behavior across these different types of creatures in our game. And then we'll come back and add it to our classes.